Hi, Srini. How are you?
Yeah, I'm fine, sir.
I'm having some technical problem. That's why I have to do differently. Yeah.
Actually, even the signing also took so long. I signed in ready, then I send photo, but then now need teacher allow like something wrong. Usually you'll be very fast one.
Yeah, usually it's quite fast. I don't know why. What's wrong?
Actually, you know the date delayed, right, teacher?
Okay. How many marks do you get? You get 11, correct?
Teacher
Out of
lagging. Teacher is
lagging.
lagging.
Yeah, something is wrong. I don't know what's wrong.
It's lagging. Teacher.
Yeah, you
Hello.
lagging. Yeah, no.
Now can hear. The date changed already, teacher.
So 11
Now
out
can
of
hear.
yeah,
Now
can hear you. Can hear you.
Okay.
11 out of 21.
Pass.
Okay, 11 out of 21. The next phase is depend very much on you. You have to do the past year paper. So the next class is Wednesday, no? Right? You don't do your past year paper. I don't think we have much time. At least 1 week we have
Sir,
to.
I can't hear you. It's lagging.
Maybe you should use your smartphone, no? Smartphone.
Another 8 weeks.
Another 8 weeks. So some of this you have to do
Smartphone for what?
two tests per week, no? Some of the weeks you have to do 2 tests per week, no? 2 quiz per week, no? And depend very much on you. Right? You have to do the past year paper, no shortcut. My job is just to make sure that you know how to answer. If you got problem, I answer for you. Okay? Any comment?
Okay.
So Wednesday, you have to do the past year paper, finish one topic. So you get 11 out of 21. Okay, let's see what is your problem.
Is that okay or bad or what, sir?
It's just a quiz only. So we can't really.
Sir, it's lagging very badly, sir. Oh, sir, by the way, the exam.
Why don't you use a smartphone? It's having
something. Hello.
Yeah.
Oh, sir, I can have class Monday. I got no problem, sir.
Let's finish today's class. Then we can decide what time you want to have for Monday.
Because it's lagging too much.
I know. As long as you can understand what is happening, you can't do anything. Lagging, you can't do anything.
30-minute class, teacher.
It's unstabilized. It's not stable. So we might as well finish it.
Okay. Is it 40-minute class or 1 hour class, teacher?
1 hour class. You already take half an hour already. You're late for class.
Yeah. So another half an hour lah.
Yeah.
Okay, can continue.
Don't know why this morning so many problems. Okay, definition, yeah, all right. Take a bit longer, that's all. Definition, no choice, and you have to get it right. Okay, can see? As long as you can see, it's all right. Ah, yeah, what is happening? Okay, the first one, yeah, all right. B. Second one, electric field lines. This one, you have a bit of problem. State which is not a properties of the electric field lines. They start from positive and end on negative, correct? They leave and enter the surface at right angle, correct?
Yes.
They give the direction of force on negative charge, no, positive charge. The line never cross. Okay? Any comment?
Okay.
See,
No, I'm okay.
all right, this one, yeah, okay. Okay, memory work only, nothing much. Okay, if it's light,
This long distance means it should be C, right?
C is repulsive force. C, you won't see this one. C is more of a magnetic field. Yeah.
Oh no. Long distance means
Where got long distance here?
Docking.
If it's unlike charges, then this is B. If it's positive, right? If this one is negative, then the answer is B. That one you must know. Memory work. This one, yeah, all right. The diagram shows the electric field near a point charge. The two directions, X, the two electrons, sorry, X and Y. Which row describe the forces acting on X and Y? Direction of force radially inwards. Right? You are told that point charge, two electron. So going out, this must be a positive charge. That is the first thing you must know. It's a positive charge. So it's going to be attractive force. Radially inwards, okay. Less than magnitude of force on X. X is nearer. So the force is going to be larger. Okay, charge is positively charged. That's the first thing you must remember. Electron is attracted by the positive charge. The nearer the electron to the point, the greater is the force as the field strength is stronger. So your answer is B, correct. That one you are all right. Right? Don't let that deceive you. Next week is your trial exam. Correct or not?
Not to say trial exam program or something.
Huh? I thought it's supposed to be a trial exam. Your
Yeah, trial, but they call it Assam Inder because they can't test it face to face. So because there is a possibility the student might copy and all that.
so you
The
do it at home and then send it to the teacher lah.
Yeah.
So if you feel you still have the strength, you can try the one in your book and then send it to me. I'll mark for you. Yeah, right. Your choice.
Which one?
The one in your book.
Past year.
Not the past year. The one in your book at the end of your book. The
Oh,
one
module. Okay.
the one we are using. I think there's one. There was one trial test I like lah, just for you to try out how well you are. Okay, you can try that one out if you want to try how well you're prepared. Okay, this one it seems to be a big problem. Distance between parallel conducting plate is D. That's a distance. A charge Q is placed near the positive plate. You should be able to read. Okay, this is your positive. This is a positive plate. X is a positive plate. You put a charge Q near the positive plate. What is gain in kinetic energy? Right, so answer is C. We are just using the definition. V equals to W over Q. So the work done is VQ. So the work done in this case is just the gain in potential, gain in kinetic energy, loss in potential energy. Can or not? Yep. Can? No? Anything? Any problem? Let me just
Okay, so just use the formula only and just derive.
formula only. Nothing to just the definition of volt. That's all. So it's supposed to be
Oh,
the work done is gain in potential energy is VQ. So in this case, the electron is being accelerated. So it's gain in kinetic energy equals to VQ. That's all. Okay. This one also you got problem. In uniform field, which statement is correct? All particles experience the same force. Yeah. Right? The electric field is constant. So any charged particle, sorry, all charged particle experience.
what did I answer, sir?
That one you have to check. Where is your answer? This one is number what?
They put that number 6.
This one you answer, I think, donkey.
Wrong or correct?
Donkey, wrong.
Yeah, I answered donkey.
Okay, let's carry on. Right, the first one is false. A charge anywhere in the field experiences the same force. Not any charge. Right? If it's electron anywhere in the field, they have the same force. But you say any charge, no. It depends because your force depends not on your electric field. It depends on the magnitude of the charge. Two things. Right? Magnetic field and the magnitude of the charge. If electron doesn't matter, electron anywhere or proton anywhere, yeah, experience the same force. All charged particles move with the same velocity. False. Right? Acceleration, we have got the force divided by mass, we get acceleration. So the charged particle will be accelerated. As long as so the velocity won't be the same. All electric field lines are directed towards the positive charge. No. Right? It should start from positive and end on negative. Now all the electric field lines are parallel, correct? Okay, uniform field. That's what I mean by uniform field. Number 7, right? You must always look at the higher one is the positive plate. The lower one is the negative plate. Right? Examiner can always play with you, see whether you understand. And it should be evenly spaced. Only towards the end is non-uniform. The end there is uniform.
Okay, this one I got correct or wrong, sir?
This one I think you are wrong.
What's the answer?
B.
Oh, I answered donkey.
Okay.
Wait, why the answer not donkey?
Why it should be donkey? The higher plate, the one with higher potential is considered positive plate. The one in lower potential is considered negative plate. That's all. Right?
Oh.
One must be positive, one must be negative. Doesn't matter where it is. It's just like placing your ball either on the ground right? Two balls, either place it near the ground or place it above the ground. The two will be equidistant apart. So it doesn't matter where you place it, either on the ground or in air at a height h, but they will still be equidistant apart. So one is lower potential, one is higher potential. Okay with that?
Okay.
High potential is considered positive plate. Low potential behave as a negative plate. The lines must be even spaced, somewhere in the middle here, and non-uniform towards the edges. Okay, I think this one you got it right. The diagram shows two metal plates P and Q, between which there is a potential difference of 700 volt. Q is Earth. What is the magnitude and direction of the electric field at point R? Right? Uniform. So we don't have to go and use, don't have to divide the 5 by 2. Right? So electric field is V over D. Memorize the formula. 700 divided by that. So it doesn't change. Right? Earth is at positive potential and negative plate is at low potential. Electric field always point from the point towards to the lower potential. Right? So that's how the E will go. And right? So answer is donkey. Okay with that? Electron volt. Right? Just memorize it, that's all. 1 electron volt, same value as the electron value, joule. Then 1 joule is just 1 over 1.6 and 10 to the power 19. 9.6, you just divide, that's all. So you get 6 volt. Okay, A. What happened to an electron moving in the direction of the uniform electric field? Remember, uniform electric field is direction of electric field, right? Means it's moving towards a negative plate. So it will decelerate first. Then it will come to a stop for a while and then reverse direction and accelerate in opposite direction. Okay? It will decelerate uniformly to rest, momentarily, reverse direction and accelerate uniformly. Okay with that? Any comment?
No.
Okay. This one, you're all right. I thought you would go to D. Electron is initially at rest in a uniform field. Which graph shows a variation with time of the velocity of the graph? Right? Electron undergoes uniform acceleration. So acceleration equals to gradient of tangent to the curve. Right? It's a velocity time graph. So there's your first semester work. So answer is B. Okay with that?
Okay.
Answer is B. Uniform time. Yeah, correct. This should be a straight line. Okay, this one is just, I think you may have got it wrong. Charge of an oil drop of mass m and n excess electron is held stationary in a uniform electric field between two horizontal plates separated by distance d. The voltage between the plate is V. The elementary charge is E, and the acceleration of free fall is G. What is the value of N? Right? Stationary. So only two forces acting. Electric force upwards, weight downwards there. So for equilibrium, your weight Right? Remember your Q is NE, number times the charge on the elementary charge. So your E is V over D, F is EQ. So your mg equals to EQ. Then replace your E with VD, right? And then replace your Q with NE. So now we want your N. Take the D across there. Take your VE down. The answer is B. Okay or not?
Okay.
Okay, you're all right. Let's carry on. Diagram shows two metal plates connected to a constant high voltage. Which graph shows the variation of the electric field strength E midway between the two plates as the distance D between the two plates increase. Right? Remember, this one, the plate is not constant. The separation is not constant. If the separation is constant and you are looking at distance within the plate, then it should be B, correct? Right? But in this case, it's no. The voltage is constant. Distance between the plate D changes. The plate distance changes, but V is constant. The voltage supply is constant because it's connected to the battery. So we just play with the formula, right? And we shall see that if it's E against D, V is constant, then it should be a rectangular hyperbola, A. Okay? Any comments?
No.
No, then stop me if you're going too fast. Which diagram represents the motion of particle in the electric field? Right? Don't need to worry about C and D. C and D are magnetic field. Right? So it's either A or B. If it's electron, the top there is positive, bottom there is negative. So it should go upwards. That's all. Okay, motion of charge in electric field is parabolic. Right? Like you throwing a ball horizontally. The top plate is positive. Right? You must be able to read. Electric field line start from positive, goes to negative. So the electron is deflected outwards. Okay with that?
Okay.
Hey, this one also test whether you know how to use Coulomb's law. The gold nucleus or radius R is represented by that. The charge on the nucleus may be considered to be concentrated at the center of the nucleus, taking E as elementary charge and epsilon naught as the permittivity of free space. What is the electric field strength at the surface of the gold nucleus? Okay, so its base memory works 79 electron times the electron. So 79 E squared. Sorry, you want electric field strength, not the force. If it's force, then it should be B. Electric
So
field.
why not E square, teacher? Why not
I'm not asking for
197?
force, You're asking for electric field strength.
Oh,
Electric field strength.
okay.
So you
So
have
the
to forget
strongest
about the
one lah.
electron.
Not you.
So it's
Yeah,
just
that means electrons the strongest lah.
So remember to read the question carefully. Examiner are very tricky. Right? So you will
Too tricky.
that's why you have to read carefully. Two charge points A and B are separated by a distance 6 cm. Electron is emitted with negligible speed.
Yeah, actually, this question they asked twice already.
Is it?
You gave it twice. Yeah, you gave it twice.
I give it twice. An electron is emitted with negligible
Yeah,
speed
I saw it twice.
from A and travel along AB. The potential difference between A and B is 600 volt. Calculate the speed. This is just using your formula, that's all. EV is half mv squared. and put in your value, charge of electron, potential difference, half. Right? Make sure you have your physics constant that you are given the exam. I won't provide for you, you provide for yourself. And then there's your V square. Calculate out. Donkey. Ken? Did you got it right? No.
Yeah.
You got it right.
Wait, 1 minute. Yeah, I got it right.
Good. Means you know how to use a formula.
Hey, wait. You put there donkey. The answer is A, Latcher.
Yeah, answer is A, sorry.
Is it power 6 or power 7?
Power 7. Yeah?
I put donkey. That means I got wrong.
You put donkey, ah.
Yeah.
Use a calculator and check and see. Unless I got it wrong, ah. Check and see, check and see. Did I got it wrong? Don't tell me I'm so careless, ah.
Yeah, correct, correct. So the answer is A. The answer is A.
Answer is A, lah. You got it wrong.
I don't want to.
Where did you
Yeah,
go?
I got donkey. Then we started times 10 is wrong. Miscalculated.
Cannot afford objective to get it wrong. Okay, cannot afford to be careless. Keep that in mind. Must check your working.
Sure, but did you notice the objective one is the one the most hardest, and then subjective and essay they don't ask the much, but then subjective essay
Yeah,
more
but you
marks.
still cannot afford to lose mark unnecessarily, lah. Answer is 1 mark usually. Right? Remember, answer is 1 mark. Check through your working. You tend to be very careless. Okay, this one can be a bit tricky. Right? ST 205 question 1. Spherical surface or radius R contain minus Q, minus 3Q, plus 5Q. Showing a diagram. What is the total electrical flux which passes through the spherical surface? Remember, they want flux. Right? They want flux. I don't know.
Magnetic flux.
Not electric field. Right? They want flux.
Yep.
Let me go with you.
Electric field means is Q over 4 pi ER epsilon R square, right? So this one is flux, so it's different. Q over epsilon.
Right? Gauss law is very popular. Right? You need to know Gauss law, the total charge. Right? Just add them up. I just modify the answer, that's all, in case you just memorize the answer. Right? So it's C. But if you want electric field, then flux is EA. And then take the A down. Right? Remember, this one is a sphere, so it's 4 pi R square. Okay with that? Are you familiar with this one?
Okay. Yeah, I'm familiar.
Why I didn't remove all the answer? Spherical conductor Y is larger than spherical conductor X. Conductor X is initially uncharged, whereas conductor Y is charged. A wire is connected from conductor Y to conductor X. Which statement is true when equilibrium is obtained? Right? Just imagine yourself. No need to draw. Imagine yourself. There's two spheres. One is Y, one is X. They connect a wire. Conductor X and Y have the same quantity of charge? No. Right? The The charge will flow when there's a different potential, not because of different charge. Right? The flow until the potential is the same. Keep that in mind. Then the current will stop flowing. Right? It's just like a ball on top of the hill will move down to the ground, to the lower ground.
So just remember that they have the same potential.
They must have the same potential, not the same charge,
Okay.
not same surface charge density or same electric field strength. No, same potential. Okay, this is the actual one. Which of the following is not a true electric potential at a point a distance r from a charge q? Work done per unit positive charge in moving the charge from infinity to the point. That one you must memorize. Correct? Potential at infinity is taken as 0. Work got out of it. Right? You don't return the energy to the, right? It's not the system doing the work. That's why it got out. This one you have to do the work because it's a repulsive force. Right? So answer is Zonki. C, sorry. Right? And you need to memorize the potential formula. Okay. Anything not clear?
Okay.
An isolated conducting sphere or radius r is given a charge plus q. The charge may be assumed to act at a point situated at the center of the sphere as shown. The potential and electric field strength at distance V0 and E0 respectively. Which of the following graph with distance of electric field and potential due to the charge plus Q? Okay, potential V0, right? Constant inside, constant potential, and then after that it goes to half. After that it goes to a quarter, right? Whereas for R is a quarter, correct? Then electric field is 3. Inside there, electric field is 0. That one you must know. At the surface is E0. After that is R squared, right? R squared, so it should be a quarter. Right? If it's 2, it's become a quarter. If it's 4, become 1/16. Can?
Can.
Okay. Charges of plus Q and minus 2Q are situated at different points P and Q, respectively, as shown. X is the midway between P and Q. Which of the following correctly describe the electric field and potential at point X? Okay, for the positive charge, electric field at X is going to the right. For the negative charge, it's also going to the right. Remember, the two of them must add up. So it's not 0, it's going towards Q. Potential is different. Right? That's the electric field formula. So resultant field is not 0, it's towards Q. Whereas potential, right? What did I write? Oh, potential is a Q, right? There's no R square here, right? So it's 2Q. No need to change it. No need to change it, right? 2Q, 4 pi epsilon naught, and then Px. But there's a negative sign here because of that one. So you have to put a negative sign there. So it's 0. Yeah. Where is the negative sign? Okay or not?
Okay.
There should be a negative sign there. I don't know why it disappeared. Okay, do we still have any more time? I think we still have some time. Might as well do some question, partial question. If you are ready to discuss, rather than let the time go to waste.
No, so far I haven't done any, sir.
Huh? You are very
No, I was doing the revision.
revision time is after you revise, you should do the partial paper already. Never mind, we will go together, we work together. Since we got time rather than waste the time.
Mm.
We will go together, we work together.
I think today got no time limit.
Where got no time limit?
Today got no time limit.
Every time must give you half an hour only.
No, because I started 9:48, then plus 30 minutes, 10:18. By right, it's supposed to show at the clock, don't have. Maybe it's got no time
You are
limit,
supposed to provide your own clock lah, to time yourself. You are late is no excuse. Even if you are late for exam,
No, that's not what I meant, sir. That's not what I meant. I mean, because we started 9:50, something like that. Now 10:22 already. Like by right, the clock's supposed to go off, but never go off means never mind lah.
okay, all this formula must be in your head. Okay, we will look at what came out. Right, you can see that every year there's at least 2 questions. Right, you can see that. Right? At least 2 questions. And then the most popular is electric potential. Right? And Coulomb's law.
Section A.
Right? Electric field.
Oh, they like to ask 2 subtopics only every year.
Topic is Gauss law.
That every year is like randomly they choose one of the two out of 4 subtopics.
So roughly, just give you some idea. At least 2 questions will come out. Okay, what's the answer? You haven't done it, go and do it now. 2 point charges minus Q and minus 2Q repel each other with a force F0. Extra charges or minus Q are then added to each of the point charges, and the distance or separation between the charge is double. The new force in terms of F0 that exists between the charges is Coulomb's law. Okay, what's the answer?
C.
Say again.
C.
Right? Use Coulomb's law. Take all the variable to one side. Right? Variable to one side. Constant, K is a constant. And this is a new one. This is the old one. Right? So you want F2. F2. That's your F1. Q2 go up. Q2 also go up. Then R2 go down. Square. Then put what is required. Right? F1 is F0. Q1 is minus Q. Q1 is minus Q. Then you tambah 1 minus Q, it becomes minus 3Q. Tambah minus Q, it becomes minus 2Q. And then R1 is R. R2 is 2R. Or else use your own way. You can do that. You can use the formula itself if you want to, and then calculate again. So answer is C. Okay with that?
Okay.
So the next class is, you want the class or you want to cancel this week class?
What do you mean?
This week you got sort of a trial exam, huh? In case you want.
The physics exam only Thursday.
So yeah, okay. You want time off to study?
How about this, teacher? Next week, Friday and Saturday back.
Friday.
So at least then I'll be like more. Yeah,
Right,
Friday and Saturday back to back.
make
Like
sure
I'll
Friday
be
you
more
do your
like
homework. Make sure you do your past year question before you come for class.
and chapter 2, this one, right? So,
Chapter 12. After that, we go to
sorry, I
chapter
mean
13.
chapter 13 quiz.
Chapter 13 quiz will be Saturday.
Okay. Okay.
So make sure you do the past year paper. So answer is C.
Wait, so 1 week, one quiz. I mean 1 week, one topic quiz.
Yep, I tried to have one, but sometimes you may have to have two.
Yeah.
Okay?
Unless they delay the exam to November or
Unless they
something.
delay the exam, but I don't think they can delay. Even like us
No,
also.
sir, we are still in, but we are still in phase 1. We not yet belong
I know.
keluar phase 2.
Ours no choice. Ours we have to ask for permission to go to conduct the exam. No choice because we cannot.
Oh yeah lah. I mean they cannot delay too long.
Cannot delay. Ours don't delay because they have the problem last time when they just have an internal assessment. Okay, electric field strength is the what's the answer?
Electric field strength. C.
Okay. Memory work definition. This one. Two identical positive charges P and Q are of equal distance from the negative charge point charge at T as shown in the diagram.
Answer boy.
Boy. When the charge P is moved towards T, the negative charge will move towards. Why do you say move towards Q? Yeah? Why do you say move towards Q? Remember, this is application of Coulomb's law. You bring P nearer to T, the attractive force is going to be greater. Before that is in equilibrium. P and Q attract the negative charge with equal force. So it becomes stationary. So you move P nearer, the force will increase, so it will move towards P. Okay or not?
Okay.
Okay. Have we finished our time or we still got some more time?
Actually, we finished already, but then I think this one is a bit lucky one. This time, like there's no time limit at all. Because you see, I sent the picture at 9:46. You allowed me around 9:50, 9:51 like that. So by right, it's supposed to be ended 10:21, but it's okay lah.
Okay, we try a few more, and then after that we won't stress you. We'll let you go. A charge plus.
I think this one today is no time limit lah.
Yeah, most likely they didn't give you any time limit. A charge of plus 3.5 Q is attracted to another charge Q at a distance 0.72 cm. If the force of attraction is that, what is the value of charge? Coulomb's law, that's all. Okay, what's the answer? Yeah, what's the answer?
Yeah, wait answer. C, the answer is C.
Right? First thing you must remember, attractive force,
Hey, boy, sorry, boy.
there must be a
Sorry.
negative charge.
Boy. Silap.
Right? We write the
Boy.
formula to find Q.
Yes, boy. Sorry, boy. Answer is boy.
Okay, boy.
Yes.
This one? Three charged
Oh.
particle minus 45 nanocoulomb plus 32 nanocoulomb minus 56 nanocoulomb are placed at the vertices of a triangle as shown in the diagram below. Q1 and Q3 are 80 cm, 60 cm from Q2 respectively. What's the magnitude of the resultant force?
So nano is 10 to the power -9, right? So
Yep. Always nano is 9. The n there, 9.
-9. Okay. C, the answer is C.
Okay. The formula, memorize it. Know that the force is attractive. Right? Know the direction. Know to calculate the value. Right? Instead of using 4 pi epsilon naught, I use 10 to the power 9. Right? 9 10 to the power 9 faster. And the other one is also attractive. Right? From Q to Q3, Q2 to Q3. Calculate out. Okay. Then form your rectangle. Resultant is the diagonal. That's your R using Pythagoras theorem. Okay, that one square plus that one square, and square root that. Right, so C.
Yeah, that's the answer. Yes.
Okay, we do the last one. After that, let you rest a bit. This one.
Okay. Metal sphere. Oh. The answer is C.
Memorize formula only. That formula. Answer is A. Okay, we'll stop here. I think I've forgotten to record, if I'm not mistaken.
No, you are recording.
Recording. Okay. Okay, you
There is
stop.
stated there recording.
Okay. Okay, you stop here. See you on Friday then.
Yeah, see you on Friday. Thank you.
Remember,
Friday
quiz
and
13,
Saturday.
quiz 13,
Chapter 2 on Saturday.
Yeah, chapter 2 or chapter 13, whichever you prefer to call it.
On
Capacitance.
Saturday. Yeah, capacitance on Saturday. Okay, noted.
Then Saturday, what do you say?
No,
Oh.
Saturday is capacitance quiz lah.
Okay, Friday is your past year paper. Remember that. Okay, you stop here.
Yeah, doing questions. Okay.
Doing question.
Any question needs to ask.
Yeah, got problem, ask. No problem, no need to ask.
Okay. Okay. Thank you, Jer.
Okay, bye.
Bye.